Thank you for joining me today. My name's Nathan Garner. I'm the Technical Pre-Sales and Project Manager here at Dynamic CCTV. Today we're going to be taking a look at the fundamentals of networking, so some of the basics of the networking side of things, such as covering IP addresses, differences between a LAN and a WAN, and then we're going to take a look at some of the different networking tools as well, and how we can find out whether or not an IP address is available on the network for our IP cameras, and also some of the theory on what a switch actually does and how that works. So we're going to take a look at a few different things this morning, and we'll start off at a more basic level throughout there, just so to give everyone more broader knowledge of networking, especially when used with IP CCTV, which is predominantly where a lot of things are going now, and even with your TVI, DVRs. They still have the ability to connect to a network, and it's great to have this kind of knowledge when dealing with different sites as well. So what is an IP address? So the IP actually stands for Internet Protocol, and this is a set of rules that governs the format of data that's sent via a local network, which would be a LAN, or via the wider area network, which would be the WAN, or most commonly would be the internet. So it's a standard that's across the planet on how data is actually sent via a network, and it's basically the identifier of the device. So it's kind of easy to think of it as your address as such, similar to how POST works. POST is sent to a specific address across the network, which can be local machine on the LAN, or it could be your external IP address when data is sent across the internet. So if you go to a website, for example, go to our website and put in dynamic-cctv.com, that is actually connecting you to an IP address for an internet server, but instead you're putting a worded address in instead of actually putting in the actual IP address of the website itself on where that is hosted on the internet. Now there is a wide variety of different addresses that can actually go from 0.0.0.0.0 all the way up to 255.255.255.255. Generally there are reserved addresses, especially on the internet or going across a WAN, and that's where you get the likes of fixed IP addresses, especially on larger managed networks. They will have, or should I say, pay for a fixed external IP address, and that makes it easier to be able to access their site remotely, whether or not be for CCTV equipment or different servers that they have on site. And those give you a fixed IP address that would be your WAN address that won't change on the system. Generally, for your normal household internet connections, the external IP address will change from time to time. And as things are growing more exponentially, especially on the internet, and there'll be IPv6 variant. So at the moment, we generally use IPv4 addressing, but there will be IPv6 addressing, which is already across on some larger networks, which gives you a lot more different IP addresses that you can actually use, and is capable of handling a lot more devices than the standard IPv4 addressing, which is this range here that you can see within those. So there's only a limited amount of IP addresses that are available worldwide, especially across the internet, and as there's more and more devices that are connecting to the internet every day, those addresses are running out within those, and so that's where there'll be the switch over to the IPv6 addressing, which in some cases a lot of networks still don't fully support. So it's catching up with where things are going to be going in the future of networking as well. So what is actually a network? So it's a number of interconnected devices. So it could be computers, it could be servers, IP CCTV, telephone systems now. Even your mobile phone connects to a network that connects to the internet via the 4G connection or 3G within that. So it can be a cluster of devices. It can just be two PCs plugged into a switch together. That would still be classed as a network. Even though it's not connected to the internet, it's still its own local network, and those two PCs will be able to communicate with each other and send data between each other as well. Within that, it doesn't have to be connected to the internet in order for it to actually be a network. A network can just be a couple of devices that are connected together and transmitting data using the IP addresses and also the network hardware. So this would be where you can use either copper, fiber, anything like that. That would still be technically a network. And with IoT become more prominent, you can even have fridges connect to a network now, the light bulbs. From there, we've even got the TP-Link extension cables now that can be connected to a network, and then to the internet, which allows you to control them from your mobile phone. So there's a lot more devices now that can actually make up a network. It's not necessarily having to actually connect to the internet either. You can just have your own segregated networks, similar to how the IP cameras connect to the back of the recorder using the plug and play method. Those PoE ports are on their own segregated network, so it's not actually even connecting to the internet, those ports on the back, unless you're using the virtual host option on there. So why do you need an IP address in order to be able to communicate? So especially with CCTV, they need a unique IP address in the same range as the rest of the network. Now, this can be different depending on the network on site. So a lot of managed networks will run VLANs, or they could have bridged LANs on site. And what that will do is you could have a camera on 192.168.200.100, for example, but your recorder might be on 192.168.1.100. Now, the third octet in the IP address, usually if that's on the same physical network, them two devices won't actually be able to communicate with each other. But depending on the network set up on site, it may be that the VLANs are configured to be able to allow the communication between the different subnets using layer 3 switching or router, which does allow you to actually connect two separate networks together, and it will actually relay the two addresses between them. So you connect back to the router via one address, and then it relays it to the IP addresses on the other network as well within that. So it's kind of like an interchange of data, kind of like your mailing offices where mail is sent in and then it's sent out to the different addresses on there, or to other distribution centers across the country. Similar kind of thought process on how that works within there. Now, for most networks, especially smaller networks, you use what's called DHCP, which is the Dynamic Host Configuration Protocol. So this allows you to be able to automatically pick up an IP address that's given out by either a switch or the router on site, and that would automatically assign an IP address that's available on that network. And that's fine for most cases. However, if you then want to be able to access the web front end of that device, it may be that the IP address gets changed, only assigned by the router for a specific length of time from there, and every now and again the router will change those IP addresses. So if you do pick up a DHCP address from the router, it's generally best, once it's picked up, to then go into the recorder or the camera and then disable DHCP so it stays on that IP address. Now, the other method of doing it is using SADP to manually assign the IP addresses, but you then need to check to make sure that the IP address that you're giving the device is actually free on the network, and you're not giving it an IP address that's already being used by another device on the network, as that's when you get the IP conflicts. And if you've ever done it before, I know I've done it myself, where two cameras have been on the same IP address, and then when they're added on the recorder is accessing that IP address, but the actual video streams change, so it will switch between the two cameras that are on that IP address within that. And that's obviously something that we don't want. We just want to be able to record the specific camera that we want to add. And also on large network, what will generally happen is the IT for the site, especially if it's connecting to their network, would give you a list of IP addresses that you can assign to your cameras if they're going on the main network. What we see a lot of the times now is that they will either create a dedicated VLAN for the cameras so that there's no one on site that connects to their network can access the web from the end of the cameras, and it segregates them with it being more secure and keeping it as a separate VLAN. The actual bandwidth that's used would still be on their main network, so that still does need to be taken into account with a VLAN. It's not like it's a separate physical connected network, but it's still using some of their bandwidth on that network, but it's stopping people from being able to access that IP range within that. So when checking the IP range for a site, the easiest way to do it is on your PC or laptop. You can open command prompt and then type in the command ipconfig, and it will give you the IP address that your laptop's picked up from that network, the subnet mask, and also the default gateway from that router or the switch that's you've connected to, depending on how the network is being configured. So the default gateway address would usually be your router IP address on that network, and this is the gateway out generally onto the internet or wide area network on the system. Now, necessarily, depending on the network, it won't always be the same IP address for the gateway as it would be the router. And so on large networks, it's always best to check with the IT that manages that network on what details need to be used for the CCTV in order for it to work properly on their network for that. Now, if it's a smaller system, such as a house, for example, that you're installing CCTV in, and you need to be able to assign an IP address manually to a camera, the best way to check if an IP address is free is to use the ping command within command prompt. Now you can see when I took this screenshot, I sent the command to run a ping on 192.168.200.210, and you can see below my laptop started pinging that IP address, and I've had a reply from that IP address. So that means that there's something already on that IP address that's on the network. So I then need to choose another IP address and look for a failure of being able to ping that device. Now, on managed networks, it may be that the devices on the network automatically block the ping command, so you wouldn't actually be able to use that on some networks dependent on the system setup. But for small home networks, it's a perfect way of being able to work out what IP range that you need to assign to the cameras or the NVR, and also whether or not there is a free IP address, which we'll take a look at live on our system. I'll go through a little demo just showing running these commands and also assigning IPs using the SADP tool as well for those. Now, we did mention IPv6 addressing. So currently 192.168.200.202 would be classed as an IPv4 address. So it has 4 octets that are broken up for the IP address. IPv6 has been created just due to the sheer growth of internet users, and it's creating more and more demand on need for more IP addresses. So IPv4 uses 32-bit and can support up to 4.3 billion devices connected to the internet. IPv6 is the newest protocol, and this uses 128-bit addressing. The actual addresses kind of look similar to a MAC address, so there is letters and numbers in those addresses, and it provides such a large number of different addresses that can only be really expressed mathematically. So it would be 3.4 times 10 to the 38th power the number of IP addresses, which is a specifically large number. It's kind of unfathomable to imagine that many. Or you could actually say it's 340 undecacillion, which I can't pronounce that word, for those. So there's that, which is going to be something that's rolled out more and more across the internet. As more devices are connected, we have to then start switching over to the IPv6 addressing to make sure we don't run out of IP addresses on the internet for those. So what is a LAN? So this is used quite frequently. It's your local area network. So this is anything that's just a local connection. So for example, if you have a switch on desk with a couple of cameras connected and your laptop, and you're just logging into those cameras on there and it's not connected, it's not going out to the internet, that would just be a LAN connection. So these exist to share information and resources locally, and it allows you to connect network devices on the same local network. So it's generally the same physical location. Not necessarily all the time. You can use VPNs to connect into different LANs. So if you've been working remotely from home, you may have been using a VPN to be able to access your storage servers remotely from your offices, and that would give you an IP address on the same network that can connect to that LAN, dependent on the system, but generally, for the most part, a LAN is just your local area network, and it's your local devices that are physically connected on the same physical network for those. Now, WAN stands for a wide area network, so this links between different LANs and/or locations. This allows you to share information over a lot greater distances, so this can be between different countries to different points on the planet. And this is connected logically rather than physically, so the two physical LANs that you're communicating with each other don't have to be physically connected to each other. It can go through different connections across the planet until it gets to the location that it needs. And obviously the largest one that's out there is the internet, but it doesn't necessarily have to be the internet. So you could have a wide area network that's connecting multiple different offices back to a main office, but that doesn't have to be the internet. It can be their own wide area network that they've created to link all their different offices together with dark fiber, for example, to connect those physically to them. It doesn't have to be the internet, it's just that the internet is a wide area network. That's how the internet actually works, connecting us all together as well. And that is currently what we're running over now with this webinar this morning as well. So you may have heard before of the OSI model, which stands for the Open Systems Interconnection Model. So this is what computer systems use to communicate over a network, and it's a visual representation to help understand how the different layers connect to each other and how a network works. And this was the first standard model used for communications in the early 1980s that this was brought about. The modern internet is not based as much on the OSI model now, but on the simpler TCP/IP model. However, the OSI model, which has 7 layers, is still widely used. It helps to visualize and communicate to people how networks operate, and also how it helps to isolate and troubleshoot different networking problems that you may come across within that. So a lot of people may be familiar with layer 2 and layer 3 switches. So your layer 2 switches works within the data link layer of the OSI model, and the layer 3 switches work in the layer 3 model, which decides the physical path that data will take. And this is where you can have your different VLANs set up on different ports on a switch. But this is generally being replaced now with the TCP/IP model. However, these different layers are still in use today, and it's still the easiest kind of way to be able to kind of visualize how it works, going from the physical layer to the data link layer, up to your network layer, and then to the transport layer on how that information is transported. Your session layer maintains the connections and is responsible for controlling ports on the system. Your presentation layer is what is used to ensure that the data is in a usable format, and if the data is encrypted, this is the layer that will actually happen in. And then your application layer is where you would actually interact with that. So that's your human and computer interaction layer within the system itself. So what is a switch? So these are devices that operate in the data link layer of the OSI model, so this would be layer 2. And what a switch does is it takes in packets of data that's being sent by devices that are connected to the physical ports and then send them out again. But unlike a hub would take in the data on one port and then it would send it out across all the other ports on that hub, and that would just fill your network with data that not everyone needs access to, and also it would be a security risk because every PC would then be able to access that data on there. The way a switch works is it will take the packet of data that's being sent via a device and it will enter the switch. The switch then reads the header of that data packet, And within that header, it says what IP address or what device it's being sent to. The switch then reads that piece of information in the header, and it will then send that packet of data out through the appropriate part on the actual switch itself. And that's how the switches actually handle the data that's being sent and received through there. And what will happen is a switch will build up a table of all the different IP addresses and devices on the network. So when the data comes in, it already knows which IP address it needs to send that specific piece of data to on there. So switches are most commonly used now. We don't really see hubs anymore. Even have them on the back of recorders. There's a switch on there as well, which is a PoE switch for those. And that's how you can connect all your different devices onto a network within that. And it only sends data out on the port that leads to the devices that the packets are actually intended to reach. So you're not getting a flood of data going out across all the ports on the network in order to hit one correct device. It's only ever sent to the device that is actually supposed to receive that packet of data across the network. So with switches, there are a few different options. You've got PoE switches, which allows you to provide power over Ethernet, and this is generally how you would power IP cameras. Or you can have data-only switches, which will only transmit data from them. And generally, you only ever used to see 4, 8, 16 and 24 port switches, but now you can get larger units which can have 48 ports that are available on a single switch. And there's different connection speeds that are available on switches, so you can get 10 megabits per second, 100 megabits per second, 1 gigabit per second and 10 gigabit per second. Now there are switches that can handle higher than 10 gigabits a second, but 10 gigabits is kind of the more frequently used ones on the higher end side of things. Now 10 megabit per second connections you don't generally see anymore unless you're using extend mode on the switches, which gives you a longer cable run, especially when you're using IP cameras. It will, when you turn extend mode on, it will drop it to a 10 megabit per second connection, and you will be able to use 6.5 megabits per second of throughput on that connection. So even though it can say that it will handle 10 megabits per second, the actual real world usage of it is normally lower than the actual what the port's rated at on the switch or on the network itself. Now in terms of connections with switches, you can have your standard copper Ethernet connections using your patch leads, in which is generally used for your connections for IP cameras and for PC connections. Or you can use fiber cabling, and you can also have SFP and combo port options available. So your SFP modules, what you see there, so this is a GBIC unit, and that will slot into the empty ports that you often see on some of the larger switches, and this will allow you to connect your fiber connection, whether or not it's single core or multi-core fiber, to your module, and that can be used as your uplink to another switch or back to the main network, dependent on the scenario. Fiber has much larger transmission distances. You can get modules that will support 500 meters, a kilometer, even 2 kilometers on some fiber modules within that. And as I'm sure everyone knows, fiber connections are a lot faster than standard copper connections and can send data at the speed of light. That's how fiber works with the transmission, and that's why we need to use these little modules to convert it back into a copper connection for the rest of the switching fabric on there. With switches and networking, there are a lot of bandwidth considerations that you need to take into account, especially when used for CCTV. Even with H.265 encoding, when using 4K cameras, for example, and using a lot of them, that can be quite high usage on the network, or just generally when you've got a lot of people viewing those cameras as well, which is creating a lot of data across the network on there. So when using 100 megabits per second port connections, Between switches, this can cause a bottleneck. So if you have, say, a 16-port switch with cameras all plugged into it, and then you want to link that back to your main switch that the NVR is connected to, if you use 100 megabits per second connection, it's not going to have enough throughput to handle that amount of cameras unless the really low resolution, even analog resolution, over that connection. So it's always making sure that you're using the right switch in order to be able to handle the throughput that you're needing for the cameras on site. Generally, the best way to do it is when using 100 megabits per second switch. If you're just connecting cameras directly into each port, that is fine, that's more than enough throughput for each camera. But then you'd use a switch with a gigabit uplink port, especially if you're going to link it into another switch. If it is only, say, 4 cameras, 100 megabit per second port would be fine. Even if the cameras are running at full whack, it would only use 16 megabits per second per camera, for example. So on smaller systems, you can use those 100 megabits per second connections. But when you're having more and more cameras running through that connection, you do need to look at having a gigabit backbone for all the interconnections between your different switches on site, especially when you're daisy chain switches, and that prevents you from having any kind of bottlenecks of where data is being slowed down, and that can cause issues with your recording of your cameras, and that's where you can see your frame drops often, or where cameras just won't stream at all just because of how much they're being limited on the network by the connection. And then to go even above the gigabit backbone connection, which would be using your copper connections, you also have fiber connections which can run at 10 gigabit per second, and that's generally used for your main backbones, or when you've got a large system where you're needing the long transmission distances that can be achieved with fiber cabling and connections instead of your standard copper connections using Cat5 or Cat6 cable, for example. Now, we did touch on internet access across the WAN or the internet. Now, generally for security, by default, a router will automatically block all network communication coming inbound on different ports. So when trying to access CCTV systems, I know a lot of people now use the Connect side of things, which allows you to be able to live view and play back without the need for port forwarding, so you don't actually have to open these ports on the firewall of the router. But generally, if you are needing to use some of the more advanced features, that's where the need for port forwarding comes in. By default, the Hikvision recorders and Hikvision cameras use 3 ports as standard. Port 80, which is your HTTP port, this is used for your web browser access. Port 8000 is for the server port, which is for the app and PC software access. And then 554 is your real-time streaming protocol port, and that allows for your live view and playback streams. That's what the video actually streams through that port. On a lot of systems now, especially since HitConnect was released, there isn't such a need for port forwarding anymore. But on larger corporate networks that are using their own DNS addresses or their own external IP addresses, they would still use port forwarding to be able to access the system remotely. And it does give you generally a much quicker connection. Sometimes on slower internet connections, on older routers, it's not always possible to use the HitConnect connection method, and in those cases our tech team would advise on manually port forwarding the router on site, and that generally speeds things up and gives you a direct connection to the actual recorder or the IP camera that you want to be able to view on the system on there. Now, I did touch on longer transmission mode with the extend mode on some of the switches that we sell, the TP Link units and the Hikvision units, but it's also built into the K series and I series NVRs. So as standard, you can achieve up to 90 meters of cable between your connection and your camera for PoE. But with the long transmission mode or extend mode, you can actually get up to a maximum of 250 meters on Cat5 running at 10 megabits per second, which would be 6.5 megabits per second of usable bandwidth. And you can get up to 300 meters when using Cat6 cable on there. So you can actually exceed the standard 90 meters PoE distance, but it does reduce the actual bandwidth that's available down from 100 megabits per second down to 10 megabits per second. And there's also the veracity units that are available as well that can actually extend it to greater distances than this. And on some of those you can run at 100 megabits per second and even 1 gigabit per second, still using copper cabling without having the need to use fiber on those as well, which is great for existing systems or when you're needing to be able to cut the costs down on the use of using fiber, because the cabling can be a lot more expensive than your copper cabling would be on there. Now, when connecting cameras straight into the PoE ports on the back of the recorder, this generally works as plug and play. And I did mention earlier that this works as a separate subnet. So on your LAN port, that would generally be connected to your main network on site, and that would give you your access outbound to the internet if it was connected to the router. So that could be on an IP address of, for example, 192.168.1.100. But when your cameras are plugged into the PoE ports, there's an automatic IP address that's been assigned to the NIC of the PoE ports, which starts as 192.168.254.1.2.3.4.5 within that. And that's where sometimes there may be a need for you to connect into the PoE ports on the back of your recorder for fault finding or anything like that. And that's where you'd need to set your LAN adapter's IP address manually to the 254 range in order to be able to access the web front ends of those cameras, because your laptop wouldn't be able to physically access them unless you're using the virtual host option, which is available in the recorders, where you'd go in on the connection on the LAN and the recorder itself would translate that and allow you to access the web front end of the cameras that are connected via the PoE ports on there as well. On that. So what I'll do is I'll just switch over onto my command prompt. So to bring this up full screen, so what I can do is if I go to ipconfig and then hit enter, that will give me the IP address that my laptop's currently picked up on our network. So it's an IPv4 address. And it also gives us the default gateway address for our system that I'm currently connected to as well. What I can also do is I can use the ping command. So if I ping 192.168.1.201, for example, and then hit enter, you can see I've got a response from that IP address and saying that there's a device on there and it's responded. If I try another IP address, you can see we're then getting a destination host unreachable. So that's a free IP address that's on our network. It's not in use by anything. So we could then assign camera to that IP address using SADP or by logging into the web front end of the camera and changing it to that IP address. What we can also do is, if for example there's an issue with cameras streams where the image is breaking up, or you're having some just video quality issues, or the camera keeps on dropping out, what you can do is a continual ping command. So your laptop will continually ping the IP address, and then you can see if there is any packet loss or if the ping times start going high. So if I do ping 192.168.1.201 and then do space -T and then hit enter. Now what this will do is it will continually ping that IP address, and you can see there we're getting 1 millisecond response times on that. Generally, if it's going across a large network, these ping times can be slightly higher, or if you're going over the wireless links, You can get generally high ping times, or if you're going connecting to the internet, if you ping a remote IP address, those ping times generally higher. You'll normally start to see issues when you get into triple figures on the ping time, and that's when you can start seeing you break up in your images, which could just be a bottleneck on the network, or it could be a damaged cable which isn't giving you the full throughput and causing the actual delay when the packets are being sent, which can then affect the video streams of the cameras. Now, as I said about being able to access different IP addresses from different octets, so if currently we're on a 192.168.1 address, but because of the way our network's set up, what I can actually do is ping an IP address that's on our technical network. So I'll just double check that I've got something on here. So you can see there, I've pinged the IP address of 192.168.200.150, and even though I'm on the one range, I'm still able to access that. And that's the way that our network's set up, so we can actually still access different IP addresses on different network ranges. Generally, if you just have a standard router on site, this wouldn't work, but if it's on a managed IT network, then they have something similar set up. So it's worth knowing that it is possible to do something like this, but it would often be done by IT specialists that would configure this kind of system setup. So if they ever give you an IP address that's different to the one that the recorder's on, it may still work dependent on how their network's set up. So it's always best to check with the IT support and just make sure that it is something that they know will work on there for those IP addresses. Now, I did mention the SADP tool. So this is Hikvision's networking discovery tool. You've also got the likes of Advanced IP Scanner, which would scan for any IP device that's connected to your network. The Hikvision one solely looks for Hikvision devices. So you can see there we've got a couple of devices that are on the network. It's very nice and easy to change over IP addresses. All you have to do is select the tick box, and you can either enable DHCP, and that would pick up an IP address that's given out by the router or the switch on site, and all we do is put in the admin password for that device on there. Or what we can do is we can manually assign an IP address. So I can use the 192.168.1.240 IP address that we tried pinging earlier, and then we can go in and enter in the password and then click modify, and that would change the device, which in this case is one of the single channel decoders, to that IP address that's available on the network within that on there. What I also want to mention as well was, I know I mentioned about the bandwidth limitations, especially when it comes to switches and how they're connected to each other. Now, it's not a straight cut on what bandwidth each IP camera will actually use. The best way to work it out would be to use the Hikvision storage network calculator. So if we go into this and go into calculation mode, what we can do is add in our different cameras. So if we say 10 cameras running H.265 encoding at 4 megapixel, 25 frames a second, and then we've got what the bit rate would be per camera. We then have a tab that is called Calculate Bandwidth. If we click on that, you can see that these 10 cameras would use 40 megabits per second of bandwidth. So you could run those through 100 meg port on a switch, for example, using the cheapest switches running at 100 meg. What you do have to manually add on is the substream for the cameras. So generally, as a basic rule of thumb, you'd add on 0.5 megabits per second per camera to account for the substream. Now, generally some cameras, especially 4K ones, run at a slightly higher bit rate on the substream, but as a rule of thumb, you work it out at 0.5 meg per second per camera. So in actual fact, for these 10 cameras, they'd use 45 megabits per second of bandwidth. Generally, the way I'd do it is I'd work it out I'd up that, generally round up, and I'd work it as 50 megabits per second of bandwidth for those cameras. And then you've got overhead when you're doing your calculations there as you're adding up your different cameras for your network. If we switch this resolution all the way up to 4K, you can see that's running at 80 megabits per second for those cameras. And then if we went all the way up to 12 megapixel, such as using the fisheye cameras, you can see the mainstream would actually max out 100 meg switch, and then you'd lose your substream, and this would start causing bottleneck issues and start bringing down the cameras that are running through that connection. So using this tool gives you an idea of the amount of bandwidth that you require for the system and how much data that's going to use. And this is something that a lot of IT networks or IT managers will ask for when devices are going to be connected to their network. They'd like to know how much data they're going to need to be available across their network for the CCTV cameras on there. And this is a nice little calculation that you can do and provide them with that information so they can make sure that the appropriate hardware is in there and they've allocated enough bandwidth on the network for the actual system on there. So that was just a quick run through of some of the basics of networking side of things, which I hope a lot of you take something away from that and that you've learned something from me there today. I do just want to mention that we do now have a dedicated pre-sales technical team at Dynamic CCTV, which you can contact us on pre-sales at dynamic-cctv.com for any pre-sales technical questions that you have, and our direct contact number is on there as well for those. So we can end the webinar there. If you do have any questions that you do want answered, please feel free to drop me an email or give me a call and I'll be happy to answer those. But thank you for joining me today. I hope you found the webinar useful and I'll look forward to seeing you on the next webinar. Thanks, bye.